Hello, my name is Jyotirmay Singh. For this mechanism sessional project, I've worked with Ayashkanta Mishra and Alapan Sen. We have taken the question number 1 of assignment number 5, which I'll show you on the next slide. So we can see the question number 1 of assignment number 5 with the diagram, which I've taken from the question number 6 of assignment number 2. So here, if you can see, we can see the term quick return effect. So let me tell you briefly about the quick return effect. So what actually happens, the wiper in the forward motion takes more time as compared to the backward motion of the wiper. So why it happens? It happens because crank rotates more than 180 degree in the forward motion and rotates less than 180 degree during the backward motion. And I would also like to tell you about the equation of no quick return effect. So let's suppose 4R mechanism system. So let's say there are 4 points A, B, C, and D. Let's suppose this is L1, L2, L3, and L4. L4 is grounded. So the equation for no quick return effect is L1 square plus L2 square equals to L3 square plus L4 square. For the simulation thing, we have used Fusion 360. And let's come about on the topic of innovative approach of ours. So we thought about some ideas, out of which I'll like to tell you. We thought to replace the rectangular bar of wiper with concave part or convex part, but some problem arises with the concave part as well as with the convex part. So while taking concave part, some water remains in the uh, end part of the window, and as well as while taking the convex part, some water remains at the top or the corner points. These are some of the things which we thought, but they didn't work. Uh, Now it's your turn, Alapon. He'll tell you about the calculation. Thank you.
Thank you, Jyotirmay. Myself, Alapan. Now let's discuss about the calculation of the area wiped by the wiper. Now, before that, let's understand the basic mechanisms for the wiper. The wiper is consisting of a simple crank rocker mechanism. Here, the link O2A is acting as a crank. The motor is placed at the O2 hinge, but it will rotate the link OA completely. Now, this will transfer the power from the OA link to the crank to the wiper present at the hinge C. Now, let's assume one thing, that the hinge C is fixed to the wiper. And now we have calculated the wiped angle of the wiper, and that is theta1 is from minus 34 to 141. Therefore, the total angle covered by the wiper is 175 degree. Therefore, the arc length of the wiper is basically the length O and D multiplied by the arc subtended by the OD link, and that is 916.29 millimeter that you can see here. Now let's say the wiper length is L, that will be kept as a parametric to get the different values of the area in with respect to the wiper length. Now after we put our wiper length L as 200 millimeter that we have used in our model, so the area came out to be 183.253 millimeter square. But the problem is we assume that the point hinge C will be fixed, but in actual mechanisms that will be not. So we calculate the actual area using Fusion 360, and that came up to be 4447.288 millimeter square. Now let's jump on to the some other features of these crank rocker mechanisms. Now let's say the O2A link, therefore the crank is rotating with an angular velocity omega. Then the power that it gives to the whole crank rocker mechanism is the T into W, where the T into omega, where T is the torque acting on the motor. Now Ayashkanta will represent the synthesis part of our model. Thank you.
Okay, thank you, Alapan. I am Ayashkant, and I will be showing the simulation First of all, let us first animate the model. So this is what the final animation looks like. So this is the wiper part, and the rotating part is the crank, which is attached to the ground below. So first of all, let us look into the components uh, of the model that we have created. Uh, so first of all, what I did was a sketch, and later I used this pipe feature with a square cross section to extrude all the sketches. Uh, After that, I created joint origins on each of the joints that we require in this figure, and later joined them with the appropriate connections. And so these are all the joints. And we also had to fix these two links. So I applied a rigid group feature here, and this part was grounded as well as this part. So this is O4 and this is O6. So first of all, when our motor will rotate, this is the crank. So this will be rotating, and this is the only thing that controls our model, the mechanism. So this is the O2A link. After that comes the AB link, which connects to the rigid body of O4C and uh, and BO4. So and at point C, we are attaching the wiper. Uh, so this is the basics of how we created this model. Apart from this, we had to calculate the wiped area. So what I did was, as you know, this point is fixed. So the distance of wiper from this point is equal to the length of this bar. So let us check the length of this bar. It comes to be 300 millimeter. So taking the radius as 300 millimeter and theta to be the entire span of rotation of the wiper. So I simply created two arcs. I simply created a sketch in which I created two arcs which were situated 100 millimeter below and above the center point. So this is 100 millimeter above. So taking this, I drew this arc, and after that, taking this point as the center, I drew this arc, from which we get the wiped area. So to calculate the wiped area, uh, I just added all these sections up, and looking at inspection tool, we get the area as 44, like 4K, 4.447 kilo millimeter square, like 4447 meter square, millimeter square. So apart from this, we can also analyze all the joints. So let me first hide all the unnecessary components. So first of all, we can see this. This is the crankshaft. So uh, rotating this, we get the wiper action. And if I rotate it anti-clockwise, uh, no, if I rotate it clockwise, then we get the same action but in the reverse direction. So in our simulation, it is being rotated in anti-clockwise direction. So this is the crank joint. Uh, if I animate the entire model, we get the same action of wiper. So this is all about simulation. Thank you.